I am Dr. V. Janaki, Assistant Professor, PG and Research Department of Chemistry, Sri Sharada College for Women, Salem 16. So in this e-content, we will see about what is meant by elimination reaction and what are the mechanism behind it and what are all the evidences in favor of this reaction. Before entering into this, now let us see what is meant by elimination reaction. Elimination reaction is a major class of organic reactions in which there is a loss of two atoms or groups that is present in the substrate molecule. It is a reverse of addition reaction. Alkyl halides will also undergo nucleophilic substitution reaction, and similarly this alkyl halides also undergoes elimination reactions. Here we can see in this example that is 2-methyl-2-bromopropane on treatment with potassium hydroxide in the presence of alcohol. It undergoes dehydrobromination and give rise to the product as 2-methylpropane. So based upon the relative position of the eliminating group, here the elimination reactions are classified into 1,1 or alpha elimination, or 1,2 or a beta elimination, or 1,3 gamma elimination reaction. So here first let us see about alpha elimination. In this, the two atoms are lost from the same carbon atom. For example, chloroform CHCl3, in this the hydrogen and as well as the Cl, that is dehydrochlorination will occurs, and it results in the formation of the product that is dichlorocarbene plus H2O and then KCl as a byproduct. In the case of 1,2 or a beta elimination, the two atoms are lost from the adjacent carbon atom. We can see from this equation that is the carbon which bears the leaving group is called alpha carbon, and then the next carbon is called beta carbon which have hydrogen. So there isn't removal of hydrogen and then leaving group. So during this reaction, there is a formation of new pi bond. Then let us see one example for this one. Cyclohexyl chloride on treatment with sodium ethoxide in the presence of ethanol, there is a formation of cyclohexene. And the next one is 1,3 or a gamma elimination. The two atoms or groups are lost from two different atoms, and these atoms are separated by another atom with a three-membered ring. So here we can see in that quaternary ammonium iodide on treatment with the soda amide in the presence of liquid ammonia, there is a formation of three-membered ring. Yes, that is cyclopropenes are generally formed in this reaction. So depending upon the mechanism involved in the 1,2 or a beta elimination, it is classified as E1, E2 and E1CP. So most commonly, this beta elimination follows an E2 pathway. So let us see what is meant by E2 reactions and what are all the examples, and in the kinetics, mechanism, stereochemistry and evidences in favor of this E2 reactions. So let us see the E2 reactions. E stands for elimination and the 2 stands for bimolecular. And then examples of the E2 reaction is isopropyl bromide on treatment with sodium ethoxide in the presence of ethanol and forms an propene, which 79% of product is formed. So here the next comes in kinetics of E2 reactions. So this is second order kinetics and it is in bimolecular, and here the rate constant K depends upon the concentration of both ethoxide ion and as well as the isopropyl bromide. So in this case, both the substrates, that is isopropyl bromide and ethoxide ions are present on the transition state, and this is the rate determining step. And the next one is in mechanism of E2 reaction. So here in this, the base, that is ethoxide ion, abstracts a proton from the beta carbon of the isopropyl bromide, and simultaneously the leaving group Br minus departs from the alpha carbon with the formation of a pi bond. Here, the electron pair that is present in the beta CH bond, it forms a new pi bond, and the leaving group Br minus comes off with the electron pair in the C-Br bond. And so this is an concerted elimination reaction. So concerted elimination means here the bond breaking and then the bond formations occurs in a single step. In the transition states, we can easily notice that there is a partially formed OH bond and then the partially broken CH bond and then partially formed C2C double bond and then the partly broken CBr bond. So we can see the energy profile diagram of the above reaction. And then here the entropy favors the formation of the products from the starting material, that is isopropyl bromide and ethoxide ions. And the next is in stereochemistry of ETO reactions. Here, the stereochemical requirement is that the groups eliminated should be antiperiplanar. The conformationally, we can say that they must be trans to one another. So the antiperiplanarity, that is, the groups eliminated has to be trans and they must have a dihedral angle of 180 degree, and this is the more favorable for the E2 reactions to occur. We can easily see from this Saho's projection and Newman projection. In Saho's projection, the hydrogen and the leaving groups are trans to one another. And in the Newman projection, the hydrogen and the leaving groups are trans anti and they have a dihedral angle of 180 degree. Suppose if it is a syn periplanar, in the case of Saho's projection, the hydrogen and the leaving groups are cis to one another, and this is a less favorable. And similarly, in the case of Newman projection, the hydrogen and the leaving groups has only a dihedral angle of 0 degree. The condition was not satisfied. The groups has to be anti-periplanar and they have to be trans conformation, and then the dihedral angle is 180 degrees more favorable for the elimination to occur. Though not in the case of simple planar, it is only a less favorable. So next we will see what are the reason for the stereoelectronic requirement of anti-periplanarity. So here in this, the sigma orbitals of the departing groups are coplanar, and this leads to the maximum overlap of the developing p orbital. And thus the transition state have minimum energy and then the maximum stability. So in the case of anti-geometry, the beta CH bonding electron displaces the leaving group from the backside, and then this attack is energetically advantageous. Suppose in the case of some elimination, the front side attack of carbon to leaving group is there. So this is energetically less favor. So thus the backside attack is more energetically favored for the anti-elimination to occur. In addition to that, the steric interactions are also minimized. In the case of anti-periplanar, yes, this one will be a more stable. The transition state in the Saho's form, that is hydrogen and the leaving groups are trans. And similarly, in the case of Newman projection, and it is easily understood from the orbital representation of anti-periplanar E to transition state, that is B2H sigma bond forming, carbon to carbon pi bond forming, and then the carbon to leaving group sigma bond is breaking. So they are all trans to each other. So here the steric interactions are highly minimized. Whereas in the case of sim periplanar, that is in the case of, we can see from the Saho's projections that hydrogen and the leaving groups are cis. And then in the case of Newman, they are very close to each other. Hydrogen and the leaving groups are. And then we can see from the orbital representation also, yes, the bond formation and then the leaving group, that is C to leaving group, sigma bonding, and then the pi bond formation, and then B2H sigma bond formations. So they are all suffering from steric and electrostatic repulsion. So yeah, the anti-periplanar E2 transition state is a more stable more stable one for the E2 elimination to occur. Now let us see the E2 reaction is a stereospecific reactions. The E2 reaction is a stereospecific reaction because different isomers of starting materials react to give different stereoisomers of the product. For example, the erythro 1-bromo 1,2 diphenyl propanes undergoes dehydrobromination to give cis product and not a trans. And similarly, this reaction is a very slower. And similarly, the 3O1-bromo 1,2 diphenyl propanes undergoes a dehydrobromination to give trans product and not a cis. So we can see from this equation that sin periplanar orientation, both the hydrogen and Br are cis to each other. So there is no sin elimination. So there is no formation of trans 1,2 diphenyl propane is not uptime. And the same, the erythro form of 1-bromo 1,2 diphenyl propanes is they undergo an antiperiplanar orientation. The dehydrobromination, there is an anti-elimination occurs and there is a formation of the transition state 1, and this transition state is a less stable due to the steric strain between the two bulky groups, that is the two phenyl groups, that is due to the more van der Waals strain that is caused by the two thin phenyl groups. So here the formation of the product is very slow. Here the formation of the product formed is cis 1,2 diphenyl propane, but the reaction occurs very slowly. Now let us see in the case of 3O form, that is 3O form of 1-bromo 1,2 diphenyl propane does not undergo a sin periplanar orientation and it does not undergo a sin elimination. There is no product formation as cis product is not formed. So here the 3O form undergoes an antiperiplanar orientation and they form dehydrobromination and there is an anti-elimination occurs and there is a formation of transition state 2. And this transition state is a more stable due to the van der Waals strain, due to the less van der Waals strain, and then the two bulky phenyl groups are placed anti to each other. So here the product formed exclusively is trans 1,2 diphenyl propene. This stereospecificity results especially from the anticoplanar transition states that is involved in the E2 reactions. So let us see the next example, that is two diastereomeric bromides undergoes E2 reactions to give two different products. Here, the two cis and trans bromooctanes on treatment with sodium methoxide in the presence of methanol. Yes, because of anti-stereospecificity, it gives rise to the two different products. That is, an alkene and as well as an alkene, alene is formed. Alkyne and an alene is formed as the major product. So here, the trans product, that is a trans 4-bromooctane. In this, we can easily see that the hydrogen and the Br are anticoplanar to each other. And this is the most suitable geometry for the E2 reactions to occur. In the case of cis isomers, the vinylic hydrogen is cis2Br, but the allylic hydrogen can easily adopt this preferred conformation, that is an anti-conformation, and forms a product that is an alene, that is octa 3,4 diene as a product. And the next one is an cyclohexane derivatives. The cyclohexane derivatives also undergoes an antiperiplanar orientation of the departing leaving groups, and it is satisfied only when the groups are in diaxial position, not in di-equatorial or equatorial axial or axial equatorial. When it is an equatorial or axial, they are syn to each other, not coplanar. When it is in a di-equatorial, the anti to each other, but not a coplanar. But when it is in the diaxial, so it is an anti as well as a coplanar occurs. So the diaxial conformation is a very susceptible for the E2 reactions to occur. So we can easily see from this slide, the group's eliminator has to be diaxial position, that is hydrogen and the leaving group, and they have a dihedral angle of 180 degree for the cyclohexane derivatives. And we will see one more example for this cyclohexane derivatives, that is neomethyl chlorides undergoes E2 elimination faster, that is 200 times faster than methyl chloride. So neomethyl chloride undergoes dehydrochlorination in the presence of sodium ethoxide and ethanol. So it gives rise to the two products. The one is a 3-mentene, that is 75%, and then the 2-mentene, which is 25%. Here the 3-mentene is the predominant product. Whereas in the case of methyl chloride, in the presence of sodium ethoxide and ethanol, here the reaction is a very slower, and similarly, it gives rise to the product as only the 2-mentene. Let us see the explanation for this reaction. So here the neomethyl chloride, and it is a thermodynamically stable conformation, and it is also favorable for E2. In addition to that, in the case of neomethyl chloride, you can see in this slide that is a chlorine which is present the axial position, and similarly the two hydrogen axial hydrogens are present. One is at C2 position and then another one is at C4 position. So this substrate can react with the sodium ethoxide ions. So it gives rise to a mixture of two products, that is 2-mentene and then 3-mentene. So here in this 3-mentene is a predominant product because it is a more substituted. The more substituted is a Sesa product, and this is the predominant product formed in the reaction. And the 2-mentene, which is a less substituted, and this is the Hoffman product that is formed in these reactions. That is the reason that is due to the presence of two axial hydrogen, it gives rise to two different product mixtures. That is 3-mentene and then 2-mentene. Here in this, the highly substituted product is the predominant product and the less substituted product is the minor product. That is a Hoffman product. And similarly, we can see for the methyl chloride. In the methyl chloride, that is a 3 groups, that is including Cl atoms. So they are equatorial. This equatorial position and this conformation is not suitable for facile E2 elimination because the chlorine atom is present in the equatorial position. For Cl atoms to be that axial, the methyl chloride has to be assume the conformation, and this conformation is of very high energy. And then the free energy of activation of this reaction is very large. Methyl chlorides undergoes E2 reaction slowly. So in this conformations, only one axial hydrogen, that is beta to the Cl atoms. So this leads to the formation of only one product, that is 2-mentene, which is the Hoffman products. And now let us see what are all the evidences in favor of E2 mechanism. And this is the second order kinetics. And then the CH bond cleavage takes place in the rate determining step of a reaction. It is a second order elimination. And this is the two-step mechanism involving the reversible formation of carbanion may also operate. And then the rearranged products are never uptime. And this is it is a concerted mechanism. There is no opportunity for rearrangement. And then the C2 reactions are also stereospecific. And so far we have seen what are all the elimination reactions and what are the mechanism, and then E2 mechanism, examples, and then kinetics, and then stereochemistry and evidences in favor of this reaction. Now let us see some quiz questions related to this elimination reactions. Which of the following statement is correct? E2 reaction is a concerted reactions in which bonds breaking and then new bonds form are at the same time in a single step. And then the order of the reactivity follows 3 degree, 2 degree, and then 1 degree. That is a tertiary, primary, secondary, and primary. In the E2 elimination, the different stereoisomers are converted into different stereo products, and then all of the above. So here all the statement above what we have seen about the elimination is correct. We know that it is a concerted reaction, and then the order of the reactivity also follows tertiary, secondary, and then primary. And then in this video, we have seen different stereoisomers are converted into different stereo products. So here option D is the correct. And then we will see the next question, that is which of the following statement about E2 reaction is false. Reactions with E2 reactions are always bimolecular. E2 reactions is generally a second order, And the E2 reactions usually occurs in one step, and then the E2 reaction usually occurs in two steps. We know that E2 reaction is a single step and it is in second order. It depends on both the substrates. That is, we can see the example as isopropyl bromide and ethoxide. And similarly, elimination, and then the 2 stands for bimolecular. The rate of the reaction depends on concentration of both the substrates. So it is a bimolecular. Okay, so here E2 reactions usually occurs in two steps is the false statement. Now let us see the one more question. Which of the following statement about E2 reaction is false? E2 reactions normally occurs with anti-stereochemistry. E2 reactions shows substantial primary deuterium isotope effects, and the E2 reactions are favored by alkyl branches at beta and alpha and beta carbons. And the E2 reactions normally occurs in syn stereochemistry. We know that stereo E2 reactions usually occurs with anti-stereochemistry, and there is a primary deuterium isotope effect will also observe, and then here the favored by alkyl branches also. So here the option D is a false statement. It does not occurs with syn stereochemistry. And then the next one is, which of the following will have the highest ratio of E2 to SN2 products expected in their reactions with the sodium ethoxide and ethyl alcohol? Methyl iodide, isobutyl bromide, and 1-bromo 4,4 dimethyl butane, and the 2-bromo 3-methyl butane. So here the option D is the correct answer. So thank you. So far we have seen what does mean by elimination, what are all the mechanism, what are all the evidences behind it, and then the stereochemistry and quiz. Thank you.